Next thing what we have to look at is one of the prescribed practicals. So apparently this is one you could be asked to do as part of your practical examination in year 12. So prescribed practical, P5, is plan and carry out experiments to measure personal power. Okay, so we need some way of measuring your own power output, either by measuring the time taken to climb a staircase or performing a number of step-ups onto a platform. Okay, we're going to do the first method, but we'll talk slightly about the second one. So this isn't our normal type of experiment, so because our normal type of experiment is how does one variable affect another? We're not changing anything here. We are just looking to measure one thing, your personal power output. And luckily this is one that you can do at home. Okay, so if we want to measure your power output, we don't have anything to do that directly, but we can use our equation for power, which is work done divided by time. Now you can measure the time using a stopwatch or the stop clock function on your phone. Work done then, you're going to have to do something that we can measure the work done. Now we have no way of directly measuring that, so we need an equation, which is work done equals force times distance. However, a lot of suggestions for this, well, you could go running, and if you measure the distance, that's great, we've got our distance, but what is the force you need to run? You know, if you run faster, you use a bigger force. If you run slower, you use a smaller force. It's very hard to measure that force that you apply to the ground as you run because it's changing constantly. Sometimes it's zero when both your legs are mid-air as you run. Therefore, it's not really a viable way of doing this. So what we do is we do something which involves you increasing your potential energy, stepping upwards. So it can either be you walking up a flight of stairs, or else we could get you to one of those it looks very big in my drawing, but one of those little aerobic step things, I don't know what you call them, and you step up, back down again, up, back down again, up, back down again. And as long as we measure in each case the total height that you've gone up, that's our distance, okay? Now, what force do you need to go upwards? Well, you need to cancel out your weight, which is mass times gravity. Gravity on Earth is 10 meters per second squared. Your mass then we measure using an electronic balance or bathroom scales. And that's our practical, okay? So let's draw our little apparatus. So it is just, and you have to do this at home, okay? You are going to run up a flight of stairs. But anytime we're drawing a diagram, we should show exactly, it's this distance that we want to know, the vertical height. What else are we going to need to measure that? You'll probably need a ruler, or a meter rule, or a tape measure. We'll talk more about that in a little second. We're going to have to measure the time. So you draw all the apparatus that you need here. So a stopwatch. And we're going to need an electronic balance. Okay, so something you can step on and measure your weight. So okay, so our method for this then isn't our normal method because we're not seeing how one thing affects another. It's just a series of measurements, really. So the first thing we will do is, let's say, measure your mass. Remember, we don't weigh masses because weigh is weight. Measure your mass on an electronic balance. Electronic balance in kg. Give any equations you need to complete this experiment. So we're going to use the equation force equals mg, where g equals 10 meters per second squared, to calculate your weight. Okay, so first step, really calculate F. Third step, calculate the distance up your stairs. Now, how do we do that? I don't want you leaning over your stairs with like a tape measure or anything like that. Count the number of stairs, or steps, to your stairs, and multiply this by the height of each step measured using a ruler. Now we're assuming each step is the same height, but if you look at the steps, they mostly are constant. So you can just measure one step, the height of one step, using a ruler, and that then will give you the total distance. Okay. Time, how long it takes you to walk up the stairs using a stopwatch. Okay, then we've got all the information we need, so we just need to do a few more calculations. So 5, calculate the work done using work done equals force times distance. Then calculate the power output. I suppose that should be your power output, because that's what we're measuring this time, using power equals work done divided by time. Okay. 6, then we can repeat an average to repeat the measurements and take average value of power output. Okay, so that's our experiment. It is a prescribed practical. I think it's actually unlikely to turn up in your exams, because I don't know if I'd want to do a test where loads of people are running up and down stairs. However, do this at home. Be careful, so don't fall over. You're not running up and down the stairs, you're walking up and down the stairs, and measure your power output. Okay?